Okay, so here we have the first method of extracting keywords from our Yale courses. For the moment we have just 3 courses, but that's because we just downloaded 3. This method would work on every course downloaded from the Yale courses. So first of all, let's see how the code will explain something about our method. Okay, so basically the first method uses tf-idf, which in a summary you can say the following about tf-idf. If a word occurs oftenly in one lecture but very rare in other lectures, tf-idf would say that that word is very important for that specific lecture where it appears very often or often. So at the beginning we have some OS code lines, getting the working directory and detecting all the courses in the working directory. Working directory is defined as the directory where our code is posted. Then we will have just this line, keywords equals keyword extraction from folder, and this is 10. Why 10? It's randomly we decided to pick just 10 keywords for each lecture, but this can be easily changed to 25, 3 or any other number. Actually a course has about 4,000, 5,000 words, so we can go from 0 to the number of the words in the courses. Then if we would go to the keyword extraction procedure, let's see what it does. So we have some let's say class word priority queue. What does this class do? For every lecture it maintains only the best tf-idf words, so we don't need to maintain all the words, just need to compare the, let's say, current word with the best tf-idf words, and that's it. Okay, so basically this class and this definition of project just calculates tf-idf for each word for each file, because the word can appear in several files. So for each file it has to have different let's say number. Okay, but before it does all this it needs to create a word database. What's the word database? The word database just is a crawler which passes through all the lectures and sees how often a word appears in a lecture, if it appears, and keeps counts also of the number of files, lectures, where the word appears. So we have to go to create word db to see what create word db. Create word db actually uses another class, it's called word, but that's not important here for the method. It's just a thing I used to make the code easier to understand. Okay, each lecture goes to a NLP pipeline. What is NLP? Natural Language Processing. And what does this NLP pipeline do? it actually gets a file, a transcript file. A transcript file looks like this. It's the actual transcript of the lecture taken by the professor, and it passes to an HTML parser. It eliminates all the noise, let's say the HTML tags, and retrieves only the words which are found in paragraphs. Okay, then we have to take all those words and tokenize them for English. What does tokenization mean? Basically puts the word in its natural form, in its initial form, not derivated or anything like this. Then it goes to post tagging, part of speech tagging, and only keeps the nouns. Why? Because we are not interested in verbs, adjectives, or anything like this. This we found from, let's say, our previous experience. So only the nouns could be keywords. And then it does some kind of lemmatization with open database. I have to say that this lemmatization doesn't work very well. Why? Because the lemmatization is made to, let's say, for common English words, not very specific scientific words, but it does its job. It does this thing for every lecture and for every paragraph in that lecture, and then returns a list of nouns for each lecture, which is then parsed to the create word database, which says this word appears in this lecture, let's say 5 times, and in all the other lectures another 6 times. Okay, so this is how it works. It's not very complicated. Actually, tf-idf is very well known. So let's run it. I'm now using PyCharm, which is a Python editor, but I can give you the source, and I even will build an exe file for let's say Windows users, because on Mac and Linux it will work as the compiler from Python is present in the operating system. Okay, so let's get test2 in our current folder, and then let's play. Okay, so the beginning it says we have 3 available courses. Okay, let's say we want to choose the second one, so option 1. I chose one course, and it says that this course is in this file. This is my current folder, but it works in every system, operating system, in every file we may put it, because it's not hard-coded. It just gets the current directory, and from there it finds out the courses. At the beginning we see that the algorithm, let's say so, it's building the database for all our lectures. You can see that for the moment it is parsing lecture number 1 out of 24 lectures in the course. So the file is transcript 01 HTML. It actually takes a little bit of time, because it has to do the NLP pipeline for each paragraph, eliminate all the words except nouns, count how many times they appear there. So it's a little bit of work to do there. It actually, the entire process takes about 5 to 10 minutes. It depends on the let's say number of words in a course. Let's say from what I've seen, course can have from 4,000 to, let's say, 6,000-7,000 words. As you can see now, it passed to the second file, 2 out of 24, transcript 02 HTML, and we'll do this for all the courses, for all the lectures. Okay, so let me be precise. A course contains more lectures. I think you know this, but I need to say it. Okay, it will take some time. Probably I will pause this video and maybe start it again when it finishes, because you'll have to see this output for some minutes. Okay, so I'll just pause it. Just let's make sure I just pause it and I don't time player. Okay, so maybe I'll just